If you've read or watched any tutorials on reactive programming, then you probably already know that reactive programming is programming with asynchronous data streams. But what does that even mean? Here's another way to think about it. Reactive programming is like taking a series of events that are happening asynchronously over time and treating them like a single collection of objects that you could perform operations on. Think of a standard collection. We'll use an array of Fibonacci numbers as an example. This collection is immutable, which means it can't be changed. Let's say we wanted to grab just the even numbers from this array. One way to do this would be to filter the collection using link's where operator. This would return a completely new collection, leaving the original array untouched. Taking this example a step further, we could chain the select operator to transform the values in our collection. For instance, we can multiply each value by 2. Again, this returns a completely new collection. The code for this example would look a little something like this. It's pretty standard stuff if you've ever used LINQ or worked with collections. A data stream is nothing more than a collection of values, except for one important distinction: time. The values in a data stream are emitted asynchronously over time. And because data streams are first-class citizens, we can pass them around as arguments, return them from functions, and even assign them to variables. Imagine a data stream of click events. Just like our previous array example, we can filter this stream using the link where operator, and transform the values using the select operator. Then we can subscribe to this feed, passing the emitted values into the function of our choosing. UniRx provides a long list of operators that can be used to filter, transform, and combine data streams, making it a powerful tool for composing asynchronous code. Treating your events like data streams and thinking in reactive will help you write your code in a more declarative way. But if you're like me and you're used to imperative programming, then writing declarative code isn't the easiest thing to do when you first start out. So let's take a quick look at an example that'll help illustrate the differences between the two styles. This mono behavior detects double clicks. It does this by calculating the amount of time that's passed between each click. If it's under 250 milliseconds, then a double click has occurred. The code for this logic is considered imperative. Imperative code uses statements to change a program's state. It consists of commands for the computer to perform, and describes how the program operates. This code contains statements that control the flow of logic, analyze and update state, and describe what operations should be executed when. Let's take a look at the same logic using UniRx and reactive programming. This code makes a declaration. It says, give me a stream of update events, but only the ones where the mouse is clicked. Then it says, collect groups of all the updates that occur within the same 250 millisecond period, and give me just the ones that contain more than 2 elements. It then takes the resulting data stream and subscribes to it. This is declarative code. Declarative code expresses logic without describing control flow. It describes what the program needs to accomplish, rather than how to accomplish it. Understanding declarative programming is a large part of learning how to think reactive. In the next video, we'll be taking a closer look at observables. Up until now, I've been referring to observables as data streams. These are the building blocks that our reactive programs will create and operate on. If you enjoyed this video, please leave a like and a comment letting me know what you thought. For more tutorials like this one, be sure to subscribe with notifications on. And if you'd like to support the creation of content like this, please consider becoming a patron on the Infallible Code Patreon page.